So I'm responsible for the developer experience in our tooling, and that's why I also conduct this presentation, because there are plenty of tools which are in my area, mentioning the installer, Qt online installer, Qt creator, and so on. But this is really getting started with embedded Linux and our device creation offering. So there will be immediately after this presentation, in the other track, there will be the advanced course of the Yocto and Yocto changes, Yocto customization. So I'm talking about how to get started, and then there will be some only people who is talking that how to do some customization. So let's start. The presentation is using just one selected hardware, which is the Toradex IMX8. This is rather powerful application processor with multiple processors, very powerful graphics processor capable of 4K rendering. This is just selected because Toradex is one of our partners. They provide very good hardware, so why not to use this? It provides very nice experience with providing the device creation software in that hardware. I'm going to talk about the very basics, really, that how to set up the host, how to get this hardware alive, what is needed, where you get everything what you need, where you get the tools, where you get the QBSPs, so the port support packages containing the complete image, what you can immediately flash into the device and start playing with that. How to start writing programs, how to deploy programs to the target. You will see that it's rather straightforward. How to choose different targets. The target may be your host. It may be any hardware for which you find the software. How to debug. And then there is a slide about troubleshooting, but this is hidden in my presentation. I'm not going to talk about much that how you do the troubleshooting, but you may study then in the material later yourself. So how to make this thing alive? Okay, power it on. Oh yeah, but how to do it from the Qt point of view? How to get software for this kind of a hardware? What you need to do to have the whole process running. So the first thing is that you will need Qt. There are a couple of ways how you can get the Qt. I will explain the Qt way, and then there is much more straightforward way provided by Toradex using the easy installer. But let's start from the Qt way. So the first thing what you need to do is that you have to log in into the Qt account. Qt account is the portal where you can download different pieces of software, where you can manage your licenses. If you have any licenses, you can manage your support tickets and so on. So first we have to install Qt, and we need some additional things, these Qt port support packages for your Qt. So in downloads, you would need first to download the online installer. There is not any specific open source or commercial version of the online installer. It's the same installer, one unified installer what we have, but this will be used to install Qt and then the QBSPs. Okay, I don't use time to do the actual download of the installer. Let's look at that, how it looks like. So this is the installer. When it's running, that you have to do some basic setup to log into the Qt account. You have to accept some of the telemetry related questions and so on. But eventually you will see this kind of installation tree where you can pick up that what you want to install. And basically, if you think what you need or what is useful to have, you should consider installing Qt to your host. This has nothing to do with your embedded device. This is completely your host related stuff. You see that I'm running Windows, so there are quite a lot of different compilers what I can use to build Qt in Windows, Visual Studio toolchain, MinGW toolchain, Universal Windows Platform toolchains, and so on. I don't do that now, but basically I would choose something what I need for my toolchain, what I use in Windows. And as I said, this has nothing to do with the embedded software, so this is not enough. What you would need is that you have to go to this Qt for device creation and choose some of the targets here. You see that the basic default set of targets is not long. There are 4 different ones: Intel, NVIDIA, Toradex, IMX6, Colibri IMX7. My target was Toradex IMX8. So where do I get this? Okay, you can see that it's already there, but it's not there by default. So I had to go to the same place where I downloaded the installer itself, so Qt account, to actually download more platform support packages, for example, for the Toradex Apalis IMX8. So let's look at a little bit that what you have here in downloads. And now these QPSPs, they are part of our Qt for device creation offering or product. So you have to have a license, device creation license, to be able to download the QPSP. So you see that I have a device creation license, and then I choose here Qt for device creation QPSP. And there will be a list of PSPs. You see that we changed a little bit the user experience so that all the Windows available Windows host available PSPs, they are extended by default. And I'm used to the old view, which is like this, that all the PSPs are just in the one list. But you will see that here we have the Toradex Apalis IMX8, the Yocto toolchain based embedded Linux. Of course, not of course, but we don't have the Windows CE images. So what we use in the device creation is that we really have the embedded Linux images created for different platforms. You have this for the Windows and Linux. You see that there is no Mac OS, so Mac OS is currently not supported. Let's see that if that will be supported in some day. And then the big difference is that I can do the basic setup in Windows for any of these targets, but if I really want to start modifying the Yocto recipes to create my own image, then I have to download the QPSPs for the Linux host. It's only supported in Linux. The download is very simple in that sense that it's a single file, quite large one, but anyway, single file what you download, and then you go back to the installer where we were. You see there is a small button here, browse QPSP files, and then whatever you have downloaded, you can then choose here the PSP file, and as a result, what you will have these additional PSPs, what you can see here. So you see that this is checked by default, and this means that I have already installed these Toradex Apalis QPSP for my IMX8. You see that there are 2 actual components which is downloaded. So there is the Linux system, which is then the image, and then there is a tool chain which will provide the root file system for embedded Linux, and then the cross compilers to build for Linux in Windows. There are additional device creation related tools here in the embedded tools in the installer. This is not related to basic getting started, but when you get progress, Qt configuration tool is very cool tool to define that what will be, or configure what will be the actual content of your Qt targets what you create. And now in Windows, as I said, Windows host, when you create or when you plan to create targets for the embedded, this doesn't make a lot of sense because you can't create those in Windows. But you can of course configure your Windows host itself if you want to optimize the memory footprint of your Qt libraries. Okay. And after you have done this kind of an installation, you have the basic tooling, but of course we don't have anything what we can put into the device and start playing with our applications. So the next thing what you need will be the Qt Creator. After the installation, you will see in Qt Creator, you will see new kits. The kit will define that what will be your Qt versions. You see that there is some Android settings what I have not completed. What will be your compilers? What will be your debugger to build and deploy software for certain targets? And what you will have is that depending what you installed, you see that I have also installed Raspberry targets earlier. So depending what you have installed, there should be auto-detected kits created for you. There will be warnings. There is at least one warning, and that warning is that you don't have any device associated yet with this kit, and you have to separately set up the device that you can start doing anything with this software. There may be other warnings, but let's look at those a little bit later. What is cool is that you can now make very easily the flashing to the target. You see that in Qt Creator there is flash boot to Qt device. And this will write this image what I mentioned automatically to the target what you define. So we will select, or we could select Toradex Appalex IMX8, and after that flash the SD card, put the SD card into the device and start playing with the device. So I have very short video which shows the idea. So you do put the Qt device, there is the USB card. Of course, you just remove it, you don't eject it. There is my IMX8, put the SD card into the device, and after that, everything is ready. You can just power up your device. Oh yeah, of course, perhaps a couple of cables should be added before you can start doing stuff. If you think that was not actually so easy, there are many phases. All these phases is described in this material, but I won't repeat it here after the live demonstration. So if you think that was not so easy, there is also a Toradex Easy Installer tool provided, of course, by Toradex. Just power up your device and select that from the menu, put to Qt and run it. And then you have to, of course, associate with the boot to Qt the right version in Qt Creator. So check that what Qt version your hardware will use, and then use the same version, select the same version in the online installer and the QPSPs in the Qt Creator. There is a link to the video, but I won't show that video right now. So now we have something in the SD card in the device, and what you do next is that you power up your device. Okay, a little bit difficult to see, but it takes a little bit time, and then there is a demo application running. And then the important thing here is that you go to settings and choose your network settings, the IP address, because this is needed to connect your host and your device. Depending on the device, whatever target you use, you can use USB as well. You can use, of course, Wi-Fi, but you see that I have very traditional wired Ethernet connection for this case now. and. After you go into the settings and look at the IP address of the device, you have to fill in the missing piece in this flow. Remember that in your kit, you don't have the device setting yet. I have it here because I have done this process earlier, but this is something which will be empty, and this is something which causes an error for you. So again, you will go to the tools and options, and then you select here devices. And in the devices, you add a new device, which will be your boot to Qt device. There is a wizard which will ask you the relevant questions to have that device. And the important thing is that if you use USB, you don't do this phase. The USB will be auto-connected. But if you use the Ethernet or Wi-Fi connection, you have to define this host name. And this will then be used to connect from this Qt Creator IDE to that device. It will use Secure Shell actually to transfer the files. And actually there is another tool which is a Qt Debug Bridge to deploy the software. And you can set also the SSH keys if you want to use that to communicate with your device, but that's not needed. The minimum is that you will define this address, IP address, or then just use USB to connect to the device. The device is given a name. You see there is just random name, Toradex IMX8, what I have given, and then you have to do manually. This is not an automatic process. You have to do manually to select from the list that you have the Toradex IMX8. You see that I don't have any other devices set up, so this will be my default boot to Qt device. And this is the basic setting. You see that there may be still warnings in your setup, depending a little bit at what kind of environment you have. For example, my environment is complaining that CMake configuration has not an environment variable, CMake prefix path set. This is actually set. This is a bug which has unfortunately not been fixed. So this is something that you don't have to worry about at all. This is just a warning. Everything works because this path is actually set in our tooling. We have to fix this, that you don't have the warning. Okay, then the next thing is that now we can run a demo image in the Toradex hardware. Of course, you want to run and possibly debug some of your own applications. There are plenty of demo applications in Qt. You can go to the welcome mode examples and pick up anything here, or then you can just create your own by creating completely a new project. And you have plenty of selections that whether it will be QML-based application, whether it will be widget-based application, whatever you think that will be useful for you. I have selected just one example, QML surface layers, just because, in my opinion, this looks nice. And I have not made any changes. This is exactly the same source code which will be available in the welcome page. The only thing which is now available or changed is that I have configured this project for 3 different targets. And I don't have more than 3 different targets. Actually, the targets, they match the kits here. You can see that I have the host, and then I have the Raspberry and Toradex Apple's IMX8 targets. So, of course, I can run this in my host only. So you can see that it's super trivial to now pick up here that what will be my targets. These are the kits what I have just configured. And I can run it in my host, and you will see that how it looks like in my host, something like this. Let's press why the control key doesn't work. You can see that there are different ways to visualize 3D data. In this example, of course, this is not very important what the example is. But the super cool thing now is that, okay, I just click here, that let the target be Toradex Apple's IMX8, and now the cross-compiler will be used to build this target for this embedded Linux and deploy it to the target. And this is a little bit difficult to demonstrate unless I will show yet another video for this. So this is actually the same example. I choose, you can't see it properly. There is an error because I was running already the same application there. So I canceled that. And the quality is not super high, and now it's deployed, and now it's running in the Toradex. This display is not attached to my PC, it is attached to my Toradex actually, and I'm using the mouse in Toradex to do the different views, or show different views of the application. So this is really the great value of Qt for device creation, boot to Qt, that it's super easy to choose different targets after you have set up the tooling, and hopefully you get the right impression that even set up the tooling is not a big thing. And of course, in the same way, it's rather straightforward to do the debugging. Wait a minute. Debugging, so you can set the breakpoints, you can set the breakpoints into the CPP code, you can set the breakpoints into the QML code. You may study that what will be the JavaScript stack, what will be the JavaScript context, what kind of variables there are. This is now C++. You can study that what kind of variables. You can even edit some of the variables so that you can provide, for example, if you have strings, you can change the string values on the fly and then continue debugging. And it's really running in the target hardware without any additional setups, except that those setups what I have already described. This is the great value. You can never know running in the host that how actually your application performs in the target, how it looks like in the target, what is the experience for the end user if you don't test. The sooner you will find issues, the less expensive it will be to fix them. So this really brings a lot of value to you. Okay, there is just another example and screenshot how to do the debugging. So this is the basic getting started with the embedded Linux. So the embedded Linux was the image. We didn't change that in any way. The Qt for device creation provides you the tool chain what you need. It creates you the image, and then you can create your own images using the Linux host operating system, what I didn't use here. So you see that I didn't do the downloads, but basically without the download, setting up the toolchain takes a few minutes. With the downloads, depending how much you download, it will take something like 10 minutes. The complete image is easy to, let's say, trivial to flash into the SD card, and then the device can be booted easily from the card. You need to set up the communication channel USB Wi-Fi between the host and the device. That was not too hard either. And debugging experience is the same as in the host. Of course, it will be a little bit slower if I'm totally honest, because we need to communicate over the Ethernet or USB to the device. So typically USB will be a little bit faster if you can use that. So that's the only difference. You can't, in the remote device, you can't debug as fast as you can do locally. That's quite trivial thing to do. I didn't show you any other tools except one screenshot of the debugger, but the thing is that all the other development tools, if you want to profile the memory usage, if you want to profile the performance, if you want to run unit tests, if you want to run the auto test for the applications, all this is supported and can be you can concentrate and start doing the development immediately in day one without weeks of setting up and creating your images for your target. Okay, this was the getting started part, and then let's look at that, what kind of questions we have. Are you Santtu going to answer, or how do we share? Can I just answer?
I've been typing away vigorously here while you've been talking, so I can keep on doing. I think you can keep the audio. Okay, good. So the first question is that what are the requirements of packages in the device, that whether there is the GDP, Dropbear, SSH, OpenSSH. So it really depends on what services you want to have. There is not that you need to have. Of course, if you want to debug, it's good to have the GDP server. If you want to have SSH connections, so we do have a tool which doesn't require SSH, which is the Qdebug bridge. So even that is not needed. But of course, in general, it's a little bit difficult to communicate if you don't have any secure communication channel. But there is not that what will be the requirements. It really depends that what you want to have. You may want, depending on the case, you may want to optimize the boot time, for example, and in that case, you will drop everything what is not necessarily needed from the middleware, from the kernel, even from the bootloader to make the boot time just a few seconds in the cold boot. So it really depends on you. There is not any minimum requirements if you just want to optimize that to create as small PSP as you want, or as small image as you want. When the code will be C++ and QML, when the code will be C++ and QML, and when it will be JavaScript code. So it's again depends on you. For example, the demo what I showed you, there is C++ code which just loads and starts the QML engine. The QML engine extends the JavaScript engine. So when the QML engine is running, if there is JavaScript functions, JavaScript evaluations, those will be executed in the JavaScript engine, in the JavaScript code. So you decide, our recommendation is that although it's rather easy to use the JavaScript code in your applications, benefit of using C++ from the performance point of view, even though we have caching and we have just-in-time compiler for the JavaScript, we have noticed that in many customer cases, executing a lot of JavaScript will be slower than executing C++. But nowadays, very often, the user interface is written with QML. The QML functionality is or may be extended with JavaScript. So this is used in the UI part. And then we have a C++ backend, which will then do networking, database access, although that's available in JavaScript as well, but often I use the C++ backend for that, and the file system access and so on. In NVIDIA image ready to execute CUDA, this is something what I have no idea. Santtu, do you have any idea of that, whether we have in NVIDIA image ready to execute CUDA? Sorry, I've been typing away and searching for a link to Jira, so can you say?
Yes, in NVIDIA image, is it ready to execute CUDA? These are the contents of
I can't remember it by heart. I think we need to answer that offline.
Yeah, and the second question is also, do you support also the DigiConnect Core 8.6? So this Connect Core 8.6, this is some target, I guess, but I think this is not in our list.
Yeah, I think generally would be saying, if you think of like what hardware do we support, what we don't. If it runs Linux, it's usually supported. We do have a quite wide range of ready-made images available for our customers, and then our partners are making those images. We offer those also, or they offer them on their websites. There are services out there who can do the images for you and help you doing those, or our professional services can do the image. And it doesn't have to be Yocto embedded Linux. It could be also something else, a real-time operating system, or some other variant of Linux and so on. So there is a quite wide range, but the time here is not allowing us to go into that part at all. We're just looking through the getting started part.
Yes. Thank you. Okay, the next question after, during the flashing of the SD device image, how does one set the root user password or key? So by default in the image, the root password is empty. There is no password required. When the device is booted, it will be the normal Linux boot. So you can actually interrupt the boot, and then you will get the command prompt. Of course, you need some serial terminal and serial connection to do this. And then you can do, you will get the root prompt, and you can do the changes what you need to do there. If you want to modify it before flashing anything, then you have to change the actual image by using the Linux sources where you have the Yocto recipes to define that thing. Can I get the recorded video for this class? So yes, the recorded videos will be available. Where I can get the link? Okay, Aris will talk about this to the recorded video. Yeah. What versions of Qt are available for IMX7? And again, this is something what I can't remember by heart. Can you, Santtu?
No, we have supported the IMX7 since it was released. So, and if I remember right, that was a couple of years ago. So that would be 5.12, maybe. I think, you can go into the account of Qt.io and look at the downloads. You'll find it there.
Yeah. Yeah, I could go there as well, but there are quite a lot of questions. So you can go to Qt account yourself, see that what will be available. And do you have steps maintained in Qt website for custom device image creation? No. And the reason for that is that we also want to sell services to customers to create high quality images. So we don't currently provide detailed instructions. There will be, in some training materials, there will be some instructions, but then that means that you have to participate in the Qt embedded training. But yes, not available in the Qt website. Where can Q&A responses be found in the archives? I'm only seeing videos. That's a good question. I have no idea.
The questions will not be published. Typically, we have our video shared.
Yeah. So if there is but then you don't have the responses. I was just saying that you can send email to me, but I don't have the questions anymore available, so I can't remember those by heart. Can we deploy and debug multiple applications to embedded Linux using Qt Creator SSH connection? That's now I'm not fully sure, but Qt Creator supports debugging multiple applications. It has been supported something like since not the previous, but the version before that, and that should work for embedded targets. I don't remember that there is any limitation why it shouldn't work as well, but I'm not 100% sure. I'm only 90% sure. How will I know when the latest Qt 5 will be supported on my embedded platform? That's a good question. Your embedded platform may be anything if the platform provider or us, we don't provide notification that it will be supported, it may be a little bit difficult except testing for yourself, which of course is quite a big thing to test all the features. I think Santtu, we don't have any let's say good answer for this. If I use MetaQt 5 from Open Embedded and my own eLinux Yocto build, do I still have to pay a distribution license for each device I ship? I have to say I have taken my own time to build this, and I don't benefit from the pre-made images. It depends what you actually use. So if you use MetaQt 5 from Open Embedded, of course, this is totally free to use. It means that you don't have any Qt for device creation. If I use my own eLinux Yocto build, yes, if you have your Yocto build, this is totally okay. So you can use, in this case, open source Qt as well. But remember that there are limitations what you can do in terms of closed devices. If you create devices where end users cannot install new applications, it's considered closed, and this is explicitly forbidden from our licensing point of view. So it means that you can't use the GPL version 3 components at all. So you have to be careful. But basically, if you just use all this is open source stuff. So depending on that what kind of devices you do, it will then define that whether it requires a commercial license or not. And you can find in our web page, look at the obligations for open source users. If you search for Qt open source obligations, you will find it, and it's explained in more detail there. Can I create a custom QBSP for microchip WLSOM? As Santtu said, if this is the Linux-based device where you have the POSIX APIs, you should be able to do that with not a huge effort if you know that what to do. Huge effort means that we do the custom port for 2 weeks, so it may take a little bit longer than two weeks. Good. Thanks. Quite a lot of nice questions. Sorry, not being able to answer all of these. We have to take some of these offline, but then somehow, Iris, we have to be able to store these questions.
Yes, absolutely. So I'll hand them over to the speaker, and then back to you, Tino, and you can respond to them after the session. But today we are at the end of our session. So as we do get close to session, please note that you can find the link to send us some feedback or join the next live session in the via the page www.qt.io/thank-you survey. You can also give us some feedback at the end of each session there, and we look forward to your input, positive or negative, so we can make improvements in the future and see if you actually like these Qt Virtual TechCon, to see if we'll continue doing this in the future. Okay, and also the Qt Professional Services is available on the live chat on the live event portal. So this portal can also be accessed through the thank you survey page as well. Right, well, this concludes our session. I thank you again for joining, Santtu and Tino, of course, and everyone who's joined today. We'll look forward to seeing you in the next session or at another time. And this video will be recorded and posted on the live event page, so please do access it again. Thank you.
Thank you all. Bye-bye.
Take care.